Okay, this is section 8.4 trigonometry, geometry. It's on page 596. Let me just talk about trigonometry. One of the only times that I will spell the whole word out is Trigonometry. You have to know how to spell it. Most of the time we call it trig. Okay? It means right triangle measure. Okay? And actually it only means triangle measure, but we focus on the right. Okay? In geometry, we basically don't get away from it. Now, there are two sections, the law of sines and the law of cosines, in this chapter that we don't do, but they are not based on right triangles. Not all of trigonometry is based on right triangle, but for our purposes, we are sticking with that. Okay? Given that fact, we need to look at a right triangle. Okay? A right triangle is any triangle that has a right angle. You understand that? It has two legs. Okay? And then across from the right triangle, it has the hypotenuse. We've talked about this, but it's important for you to understand. It's important for you to understand all the things about a right triangle. Okay? Thank you, Gigi. We're on page 596, Gigi, section 8.4. The hypotenuse is the longest side, always. The two legs do not have to be equal. They can, but they don't have to be. We label a right triangle as the two, what we call complementary angles, because they add up to 90 degrees, as capital A and capital B. Most of the time, this is capital C. Now, the side opposite angle A is this side. Do you understand it? We call that little a. The angle B, the side opposite is, we call it little b, and the side opposite hypotenuse is C. And that's where you get the a squared plus b squared equals c squared thing of the Pythagorean theorem. Remember that? Mm-hmm. Okay, I like to say leg squared plus leg squared equals hypotenuse squared. Okay. Any questions thus far? Okay. Today we're going to talk about a ratio. All right triangles have certain ratios that are true. Okay? And I'm going to teach you the long version, and then I'm going to give you a shortcut. It was funny, I was talking to Joel today, right as you came in, Joel, Mr. Carr, and I said, he says, what are you talking about today? I said, trigonometry. And he said, oh, Pythagorean theorem. And I said, well, we're going into the ratios, the trig ratios. And he goes, oh, so katoa. He knew it. Okay, he's been removed from school for quite some time, and that concept, but he remembered so katoa, and that's what I'm going to teach you today. It's a catchy little phrase, but it actually works, so that's why it's important. So we have three ratios, all right? And I'm going to pick an angle. Now, when I pick an angle, I stay away from C. We don't take the sine, cosine, and tangent of C. We take it of A or B. Now, I'm going to choose A because it's first in the alphabet, but it can go with B also. And I'm going to say the sine of A, okay? So this is how we write it. No, this is how it's said. This is how we write it. So we abbreviate it. We only take off the E. It is not pronounced sin, okay? It is sine, the sine of angle A. Now I could take the sine of, I should probably have an angle there, angle sine. I always take the sine of an angle. The sine of an angle is a ratio. This is a ratio. A ratio is a fraction, Harper. One number over another. You understand what I'm saying? The ratio of sine of angle A is the opposite leg of angle A over the hypotenuse. Okay? So opposite, the ratio is this length over this length. You understand what I'm saying? So it's basically little a over little c. Does everybody understand that? If I was to take the sine of angle B, it would be little b over little c. Yes?
That's a little a over a little c.
Yes, that's a little a over little c. Now I could switch and take the sine of B, but it would be a different ratio. It would be this over this. Do you understand it? I do not take the sine of angle C. I only take the sine of the two complementary angles. Do you understand? Does everybody understand it? Okay. So now I'm going to talk about cosine of angle A. Okay, cosine of A. Cosine is abbreviated COS of angle A. Okay, but it's pronounced cosine. So we have sine and cosine. Okay, it is the adjacent leg of angle A over the hypotenuse. Okay, so it is the adjacent would be little b over c. Now, if I took the cosine of angle B, it would be this adjacent leg A over C. You understand? So it depends on what angle I'm taking it at. Okay? Finally, if I take the tangent, T-A-N tangent, T-A-N-G-E-N-T, the tangent of angle A, which is T-A-N of angle A, it is the opposite leg of angle A over the adjacent leg of angle A. And once again, angle A. Once again, if I was to take angle B, it would be a totally different thing. Okay? That this is the opposite, which is of angle A is A over the adjacent, which is B. So it's A over B. Does everybody see that these are ratios?
Do all these equal each other?
Okay, so in every right triangle that can be created, the sine of an angle, 36 degrees, is always the same ratio. Comes out the same. So the sine of 36 degrees in any size right triangle, you can have big ones or little ones, right? The ratio of the opposite side over the hypotenuse is always the same. The ratio of the adjacent side over the hypotenuse it's the same. And so, same with the tangent. That's always the same for any right triangle. So what we can do is we can solve for unknowns. Without using the Pythagorean theorem, we can solve for unknowns, given an angle. And I'll show that to you in just a minute. But I want you to try to remember this by this saying. This is what Mr. Card said when I said, oh, we're going to study trigonometry. He said, oh, soa katoa. Soa, however you want to do it, is sine is opposite leg over hypotenuse. Cosine is adjacent leg over hypotenuse. And tangent is opposite over adjacent. You see where they get that?
Mm-hmm.
And I have students that write this at the top of their test. That's not cheating. The minute I hand them the test, they write soa katoa.
So, can you say it again?
Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Got it?
And then you said for the it's cosine.
Cosine is adjacent over hypotenuse. Okay? So if I have a triangle like this, a right triangle, okay, and I make my right angle here, and I'm going to change the letters on you now. Q, P, R, and I'm going to say this is 15, this is 17, and this is 8. Now, whenever you give me a ratio, it has to be in simplest form. If you don't have it in simplest form, it's wrong. Carly, in the book, the author did not put it in simplest form. So when you check your work, make sure that you put it in simplest form. I tried to write in there what the simplest form is, but he didn't do it. I don't know why. Okay? So if I say the sine of angle Q, let's say, okay? The sine of angle Q. Then I go up here and I look for angle Q, and I know that sine is opposite over hypotenuse. So I take the opposite leg, which is 8, over the hypotenuse, which is 17. Okay? So it equals 8 over 17. Now, if you get a calculator out, and because they're going to ask for a decimal, also in some of the problems to the nearest hundredth. to the nearest hundredth. How do I find a decimal 8/17 to the nearest hundredth?
Divide 17 by 8.
How about 8 divided by
Oh, yeah,
17?
shoot.
And what do you get?
0.47.
That means any right triangle, the sine of that angle with that ratio is 0.47.
And to be
Yes.
sure,
Yep.
But what's the definition of sine?
Sine, the definition of sine is the ratio in a right triangle of the opposite leg over the hypotenuse. Yep, and the definition of cosine follows, and the tangent follows. That is the definition. We've created a word for that ratio because we use it so much. Isn't that weird? Okay, so what is the sine of angle P? Really, the sine of angle P is
15 over 17.
15 over 17, which is what?
0.88.
Okay, and does it continue on 88888?
no.
Okay,
2, 8,
okay,
2,
okay.
3, 9.
Because we went around correctly. Sine and cosine will always be 1 or less. They will never be greater than 1. Okay, tangent will be. So let's do a tangent. What's the tangent of angle P? Tangent, if you look, is opposite over adjacent. So the opposite of P is what?
15 over 8.
15 over 8. So that is what? As a decimal.
1.875.
So 1.88.
1.88.
8.
Okay, folks, believe me, if these fractions are not simplified, please simplify. Let's do a cosine. Let's do a cosine of angle Q. Gigi, what is the cosine of angle Q?
Should be
This
this.
would be, wouldn't it be 15 over 17?
Yes, we've already
It's
done
the
that.
same
So
thing.
it's the same thing.
All right, it's 15 over 17, adjacent over hypotenuse, so it's 0.88. You see how some of them are the same, right? Depending on what we take. All right? Questions about that? All right, now we're going to look at a 30, 60, 90 triangle. This is 30 degrees, this is 60 degrees, and this is 90. Across from the 30, we're going to have x. Across from the 60, we're going to have x times the square root of 3, and the hypotenuse is 2x. Does that look familiar? Exactly, it does look familiar. We know in a special right triangle that across from the 30 is a side, across from the bigger one is that side times the square root of 3, and the hypotenuse is twice the shorter leg, right? Okay, so let's call this, I better label it or we'll be in trouble. Well, actually, no, let's just say this. What is the sine of 30 degrees? Okay, what's the sine of 30 degrees? Well, I take a look at the 30-degree angle, right? It doesn't have a name, so I say the sine of 30 degrees equals the
X.
opposite
leg of
over hypotenuse.
So x over
2x.
2x.
It's x over 2x, right?
So it's
What happens to the x's?
1/2.
They cancel. So what do I have on top? Be careful, it's not 0.
1.
1. Did you know that the sine of 30 degrees is 1/2? Would you please push sine on your calculator? It's SIN. And then push 30 equals.
0.5.
Isn't that 1/2?
That's easy.
Yeah.
Every right triangle in the world, if it has a 30-degree angle, the sine of it is 1/2. Okay? Would you please find the sine, this one's going to be uglier, of 60 degrees? What is it?
0.8.
Oh, no, not on your
6.
calculator. Let's find an exact answer first. Okay, so sine is opposite, so opposite is x
Square root of 3.
3 over 2x, right? All right, the x's cancel, correct? So I get the square root of 3 over 2, right? All right. Now, just for fun, take the square root of 3 on your calculator, divided by 2, and tell me what it equals.
1.2.
1.86, same thing that I just got.
What?
1.86.
No.
What?
Arbor, I don't think so.
I just
Yeah,
got
it is.
1.8.
That's the same exact thing
You
I
got
just
one
said.
point
I got
eight?
no, it'd be
Yes.
1.9 if you put round up
Okay, well then we
8.6.
done screwed up.
It's
Yes.
0.87.
I got
I got
3.46.
0.87.
Seven.
Zero point
Okay.
eight six.
Yes, that's the exact same thing I got when I did it on my calculator the first time you said
You
no.
got point eight six six.
That's exactly what I got the
Okay.
first time when you said
And so when you did the sine of 60 degrees, did you get point
Yes.
eight?
All
So
three
it
times.
works, right?
Mhm.
Okay, alright. You understand what I'm saying?
So basically we could write that down as our answer.
No, because I'll ask for an exact answer. This is an exact answer. The one on your calculator is not an exact answer. The one on your calculator goes on and on and on and on. This is an exact answer, okay? They're irrational numbers, just to tell you that, right? Okay, you understand, well, let's do tangent of 30 degrees, just because we need the practice. The tangent of 30 degrees, okay? A tangent is opposite over adjacent, right? So opposite is what? X, and over adjacent is?
X squared 3.
What happens to the x's?
Cancel.
They cancel, so I get 1 over square root of 3, but you cannot leave it like that.
Got
It
it.
must be rationalized, so I must take it times the square root of 3 times the square root of 3. So it is basically the square root of 3 over the square root of 9, which is
Square root of 3 over 3.
the square root of 3 over 3. It's tangent. And if you check it on your calculator, it'll come up the same.
577.
Okay, so what's the advantage of these? Well,
No.
watch this. Number 1.
Is that on our quiz or homework?
Yeah, no, this is not, this is, but this is like, I don't know. Okay, I'm doing good.
Whoa.
I was a little confused there. Okay, you see, you cannot use the Pythagorean theorem here, right? Because we don't have the hypotenuse given. So what do? Well, you use the concept of trigonometry. You go, okay, all right, I look at the angle that's given. It's this one right here. I look at its relationship with the two other sides given. And I'm just going to tell you what it is for now, and you're going to have to figure it out later. But at 25 degrees, I have the side across from is what I'm looking for. So that would be opposite. And then I have the side adjacent to it would be tangent. So I can use the tangent function to do this, and I'll show you how. The tangent of the angle, which is 25 degrees, equals the opposite x over 18. All right? Now, here's why I do a little trick that helps me out. Not now, you're going to go, why do you do that? But in a different kind of problem, it'll help you out. I put this over 1. Now I have a fraction equals a fraction. Do you understand that? And a fraction equals a fraction is a proportion. And in a proportion, the product of the extremes is equal to the product of the means. Ooh, wait a minute. Wow, this is all coming around again, isn't it? Yes. Okay, so I multiply these two together, and I multiply these two together. So I have x equals 18 times the tangent of 25 degrees. All right, now we're going to round to the nearest 100. I can find out what x is. Take your handy dandy calculator, or Kyle, in your case, the 3 calculators you stole from me. All right, so take your.
That's not me.
That's going to go out on everything, man. Social media. Okay, so 18 times the tangent of 25 degrees. So I push 18 times the tangent of 25 degrees, and I get what, Carly? 8.39. The value of this is 8.39. So you can actually find the length of it based on trigonometry.
Not even doing any work, I just pull it all in my calculator.
Your calculator does it all. And that's a good point, because in my day, it didn't do it all. I did it all.
Because you were on chipping stones.
Yeah. Yeah, you're right. Easy. Easy there, killer. I can't say anything, you know, I'm on video, so it will come back to haunt me, right? Trying to tempt me, so, you know. All right, so here's a case where I find the angle given. Now, you can find this angle if you want, but my advice to you is to always use the one they gave you. That way you don't make a mistake.
Does that say 70 degrees?
That says 70 degrees. Okay? So I find the angle that is given, and I look at the two sides, the one I'm trying to find and the one that is given, and I try to decide what function I'm going to use. And so I look at it and I go, okay, this is a leg and it's adjacent to it. So there's a, and then this is the hypotenuse. So I go over here and I go adjacent and hypotenuse. Adjacent, hypotenuse, I use cosine. You see how that works? So then I say the cosine of 70 degrees equals the adjacent, which is 15 over x. Okay, now here's the one I wanted to show you, because here's the one where this proportion really makes sense. I put this over 1, correct? Now I multiply these two, and then I go x equals, x times cosine of 70 degrees equals 15 times 1, which is 15. You all agree with that? See, now I actually have to do something here, Bo. I have to solve for x. I have to divide both sides by cosine of 70 degrees. So this is a different kind of problem, right? And so now I go x equals, and I just plug in 15 divided by cosine 70 equals.
15 times.
No, 15 divided by. Harper, I'm dividing by.
43.86.
43.86, and that's a length, isn't it? All right. So now I can use any one of the trig functions based on the information that I'm given. Do you understand that?
Yep.
Okay, but one thing we haven't talked about is, how do you solve for an angle? Okay, how do you solve for an angle? In other words, if I have a triangle and I'm trying to find an angle, if I have a right triangle, how do I find it? So let's take a look at one of those. What's that?
To myself.
Well, all right. Let's say that I have this triangle. And the question asks, what is the measurement of angle A? What does it equal? Okay. Well, you can use trig also. I go to angle A, and I look at it. It's right here. I'm going to mark it, and I'm going to mark it so I know which angle I'm talking about. And I say, okay, I have this side and this side. If I look, according to angle A, that is the opposite,
Tangent.
and the hypotenuse.
Opposite S sine.
Sine. So I take the sine of angle A, you understand what I'm saying, equals the opposite, which is 18 over 27. You got it? When I'm finding for an angle, there are two different things than finding for a side. Number one, I don't put it over 1. Okay? I don't put it over. Number two, I don't use the sign button exactly the way it is. I use what we call the, what is this book? Gotta be careful here. The inverse sign button. All right, what do I push? What I push is, I push the, it's called the inverse sign. Let me write it down. But what it is
-1.
second, that second button up there, sine 18 divided by 27 equals. And we want to round these to the nearest
41.8.
nearest tenth. We want to round, so it's what?
41.8.
41.8 what? 41.8 no,
Degrees.
degrees.
Oh.
Notice that my sides, when I find a side, I go to the nearest 100. When I find an angle, I go to the nearest tenth, and it's a degree. And anytime you're looking for an angle, you hit second sine, second cosine, second tangent. You understand what I'm saying? I'm going to give you another one to practice on. Anytime you find an angle, we're going to hit second. Dawson, do you understand it?
Yes.
Okay. This is A, this is C, this is B. Remember, we're finding for angle A. The measurement of angle A equals a degree. All right, I'm going to give you this and this. Okay, now I don't want you to talk. I want you to just figure out which trig function, I'll ask you in a minute which trig function we're gonna use. Here's SOHCAHTOA. What's given? What do you have to find? According to angle A. According to angle A, what trig function, Gigi, should I use? This is angle A.
Yeah.
I have this side, which is, according to angle A, which is what?
G.
Yeah, but
Oh, wait.
is it hypotenuse,
Oh,
adjacent,
it's
or
a
opposite?
leg.
It's a leg. Which leg? Adjacent or opposite? Of A.
Adjacent.
It's adjacent.
Yeah.
And then this side is?
Would be cosine.
It's cosine. It's adjacent and hypotenuse, which is cosine. So I would say the cosine of angle A equals, remember we're going to hit second, equals 3 over 15. So now I'm going to hit second, and instead of sine, I'm going to hit second cosine. 3 divided by 15 equals 74. 78.5 degrees?
Yes.
A little bit.
Okay. Do you understand what I'm saying? And so trigonometry can do things that the Pythagorean theorem cannot. Okay? All right, so your assignment for Monday is page 601, numbers 16 through 20 even. So 16, 18, 20, and then 21 through 43. Okay, on 16, 18, the book does not simplify the fractions, and I want you to. It says find sine of j, cosine j, tangent j, sine of L, cosine L, and tangent of L. Express each ratio as a fraction and as a decimal to the nearest hundred. I want you to say express each as a fraction in lowest terms and as a decimal to the nearest hundred. Okay? We're only doing the evens because you have to find 6 of them, okay? But make sure you simplify that fraction all the way down. The book does not do that. Okay? And it should. Any questions? Okay. Josh, you want to